Anyway, we probably, but anyway, let's see what the democracy says here. Just a second. Let me get this. Let's see what the. Oops. Okay, let's see. Democracy, the majority answer is 14,000. There are a few that were different, but only one was different. Okay, so the democracy says, the majority rule says it's 14,000. Is that right? Yeah, that's right? Because we said 8%, no, sorry, we said 8 years at 5%. So that's 8 times 5 is 40% altogether. So 40% of 10,000 is 4,000. So we get $4,000 interest. We get the present value was 10,000 plus the 4,000 is the 14,000. Okay? Anybody have any questions about that? I guess nobody does, except for maybe one person, which maybe they wrote the wrong number there. Okay. All right. So now, okay, so that's the homework on simple, it's called simple interest. What we just did is called simple interest. So there's a set of homework problems. Actually, there's 2 sets of homework problems on simple interest. Okay, now the other topic is called compound interest. And the only difference between compound and simple is that in the compound example, you leave the money that you got as interest in the bank. So we said that, for example, over here, we said what? We had $100, and we said the interest rate was 10%. So how much, if you put in $100 and you get 10%, how much interest you get? $10. Now the only difference is that in the second year, so we said we're going to do it for 3 years, but the difference is that in the second year, you left that $10 in the bank. So what's the difference? Yeah, so you, in the second year, you don't have just $100 in the bank, you have 110, so it's different, right? You're not going to, the calculation is going to end up different, right? So you're going to have to figure out what? In the second year, you're going to have to figure out what's 10% of $110. What is 10% of $110? $11. So the interest in the second year, we thought it was going to be $10 in the second year, but it's not. It's a little bit more. It's $11. Okay, so now, in the third year, we thought the interest was going to be $10, but now it's going to be 110 plus 11 is going to be in the bank at the beginning of the third year, right? Because you got $11 at the end of the second year. So you're going to have $121 in the bank at the beginning of the third year, right? So then what? How much interest are you going to get on that? 10% of that, which is 10% of 121, which is not $10, right? So it's going to be plus, what is it? 12.1 at the end. In the third year. So we had 121 plus 12.1 is 133.1. But we already figured the answer before was 130, right, when it was simple interest. now we get a different number, of course, and it's what? 133.1. So how much extra did we get by leaving the interest in the bank? $3.10. Right? So it's not the same anyway. Right? Because we left the money in the bank, so we get interest. They say we get interest on the interest. Right? We get interest on the interest. So that's obviously a different calculation. Right? So, so you can't use the formula that we have. Right? I mean, you'd have to adjust it somehow. Right? Because the formula that we had would say we had $130, but we just figured out we're going to have $133.1. Right? Okay? So that's the difference between simple interest and this other situation, which is, we give that a name, that's called compound interest. So compound just means like, kind of like adding into or something like that. So it's like you're adding the interest into. Okay, so that's compound interest. Okay? So the thing is, it turns out that the formula for it works out pretty well, actually. So why don't we explore trying to come up with a formula for the compound interest? Because it turns out to work out fairly nicely. So let's try it. So let's try that. So let's say that we're going to, so let's figure out what the future value is after the first year. So after the first year, it's the same as the other calculation. So it's equal to PV times 1 plus RT, because we didn't leave anything in there. We only left in the present value, so there's no extra after the first year. So this is, let's say, after 1 year. Right? It's that. Okay? Okay, now we ask what's going to happen at the end of the second year. So, okay, so at the end of the second year, it would just be twice as much interest, right? Because the present value was still just like $100, right? But now the present value is not $100. What is the present value? The present value is how much it was worth at the end of the first year, right? Right? The present value at the beginning of the second year is exactly how much it was worth at the end of the first year, because the end of the first year and the beginning of the second year are the same thing. Right? They're just different words. The end of the first year and the beginning of the second year means the same thing. So, how much do we have in the bank at the beginning of the first year? The amount that we had at the end. But it's not PV anymore. It's this. Right? That's how much we have in the bank at the beginning of the second year. Right? Okay, now, so normally we would just say, oh, what is it going to be? It's going to be PV times 1 plus RT. But it's not the same PV that it was before. Right? It's actually this. Right? And actually, we don't use this T anymore. because we're writing out year by year, so we don't use the T. Okay, we're just writing it out each year, so we don't use T. Okay, so what is PV? It's this. This is like the PV, I guess I should say PV at the beginning, right? So we take, and this is what? FV, what should I put here? FV1? Or, I don't know what to write there, but anyway. So that's what goes in here. So in other words, this goes in here. So this is like PV1. PV1 is equal to PV0 times 1 plus R. Right? So if I replace that, I get this. PV0, 1 plus R is this part. Right? And then I still have to multiply that times 1 plus R. Right? Everyone see what I did? Of course, the future value of last year is how much I have at the beginning of this year. So that's what I did. I put in that. Okay? And then we can do it after after 2 years. So what's that going to be? So in general, it's going to be how much you had at the beginning. That's your new present value, because our present value is changing. So how much you have at the beginning, and what should I call this? FV2, by the way? Okay, whatever we call it. So it's going to be, so FV3 is going to be what? The present value at the beginning of this year, which is this. Which is this. Right? So it's PV0, 1 plus R, and this is actually 1 plus R squared, right? So that's just this is the present value at the beginning, and then we have to multiply that times 1 plus R. Right? So now what do we have? So this is actually PV 1 plus R cubed. Right? And what's going to happen as we continue to do this? It's just going to happen over and over again, right? So at the end of, after 5 years, what's the formula going to look like? It's going to be PV0, 1 plus R to the 5. Okay, so that works out pretty nicely. If it didn't work out nicely, we probably wouldn't study it. They wouldn't teach it to us if it didn't work out nicely. They'd just say, there's nothing interesting about it. You just have to do it manually and, whatever. But it turns out to work out nicely, so that's why we even bother studying it, I guess. Okay? Anyway, it does work out nicely. PV times 1 plus R to the 5. Okay? So if you want to know, after... Now what was the, if we didn't, that was called compound, but what's the simple again? Simple interest, what would that be? FV equals PV times 1 plus RT, or, so in this case it would be what? PV 1 plus, I'll leave in R, times 5. So that's different than this, right? And we can guess that this is going to be bigger than this, because if you leave the money in the bank, you expect to have more at the end. So we can guess that this is going to be bigger than this, right? Okay, so why don't we do this calculation? So let's go back, let's do it both ways. And let's say that we start out with 10,000. So that's our PV, or maybe we should use PV0 now. Anyway, that's what we're starting with. And let's say the rate, let's make it simple, 10%. And we're saying T equals 5 years. So let's figure it out both ways and see what the answer is. Now, again, we expect that this way is going to be bigger than that way, and this way is going to give us what? This is easy to do. So this is 10,000 times 1 plus 5 times 0.1. Right? So that's $15,000, right? Okay, so if we just do it the simple way, we get 15,000. Right? Everyone agree with that? Okay, now hopefully this is going to give us a bigger number. So, okay, do it yourself. Because I don't have a calculator. So you have to put in, just this part is good enough, right? You don't need to do the 10,000. Just say 1 plus r, so 1 plus 0.1, which is 1.1 to the fifth. You just need 1.1 to the fifth. One point, sorry, 1.1 to the fifth, that's this part. So, what do you get? 16,105. 105.1 he gets. Everybody get the same thing? Okay, so it was bigger, right? It was bigger by $1,000 something dollars. Okay, so that's the compound interest formula is this. Okay, so everyone see where it came from? We just remember what we have to do? We said after year, we said at the end of the first year, it's going to be the same, because we don't have any extra money in there. But then at the beginning of the second year, our PV is different than it was at the beginning of the first year. Right? So the new PV is the FV from the end of the year. So we replace that PV with this. Okay? And then we see that we get two terms that are the same there. So we square it, and then we see that it's going to continue like that. We're going to get cubed, fourth, and so on. And the other thing is we took out the t here, because we're doing it year by year, so we don't need t in there. Okay? Is that clear? So this is the compound interest formula. All right? Anybody have any questions about that? Okay, now let's change it a little bit, because it's about money. And since it's about money, people always want to think about doing some other way. So, let's see. Okay, here's a question. Suppose I gave you a choice. I'll give you 12% interest. That's 12% per year. Or I'll give you 6% interest every half year. I'll give you 12% per year versus 6% every half year. So at first thought, you say it doesn't make any difference. Okay, either way it's the same thing. Right? But if you think about it a little bit more carefully, which is, if you're just thinking kind of generally about problems, you might say, oh, it's just the same thing, And then somebody else is paying really careful attention. And so, you know what, there's something called, what's that disease? It's kind of like autism. Begins with an A. What is it? Not ADHD. What is that called? What is that called? You know what autism is, right? Asperger Syndrome. Have you heard of Asperger Syndrome? So if you know about the story about the stock market crash in 2008, what happened was the banks in the United States, they started, all these finance guys decided to buy up lots of real estate debt and then sell that. And they packaged it up in these very complicated ways. They used a lot of formulas probably. Anyway, they packaged it up and made it, and they thought, here, you can buy this debt. This is that people have to pay their mortgage. Now you'll get that money from them. Okay, you buy the legal right to do that, and then you buy it for a certain amount. Like suppose the actual amount of the mortgage is $100 million. It's like a bunch of people's mortgages. So it's worth, let's say, $100 million or even $1 billion worth of mortgages. But you're taking some risk, right? So you can buy it for $700 million, right? So they made these deals. The guys that they went and they talked to the people that owned the debt, and they said, look, we'll take this over, we'll package this up for you, we'll sell it for you, and how about that? And they said, okay, that sounds good to me. I want the cash now, so I'll take the money now, and somebody else can get more later, right? And so they fooled around like that, and then it turned out that all these mortgages were like baloney, it was like nonsense. I mean, at that time,